in solving this problem, we're going to have to use the law of adding signs, which is going to be sine A plus B equals sine A cosine B. It's cosine A times sine B. Now, this is going to become pretty involved since these are not simply A and B, but rather inverse trigonometric values. That's hard to say. So let's go ahead and make note of what A and B are here. And A in this case is going to be cosine negative of cosine arc cosine of 2/3, and the B is going to be, we'll have to include that coefficient there, 2 times arc sine negative 1/3. Now, if at any point this gets confusing or anything, or there's a point where it could be made more efficient, see counter solutions, because at some point there is a part that might use an identity that I did not memorize, but this is the way that this does solve it in any case. So let's go ahead and get into it. So first what you want to do is you want to plug in these values right here and here. So let's go ahead and do that. Sine is going to turn into one massive thing, but this whole thing right here is replacing all of this. So remember that all of this is going to be unnested, so to speak. So this is going to become this A, so this goes here, here, and then we're going to multiply that by cosine of this, so that's going to be 2, 1, 1/3. Now, as you can see, these are not going to match up properly unless we define this in terms of cosine and this in terms of sine, and we'll do that. But this side is going to be a little bit more simple since that's going to match up with A and B, cosine and sine. So that's going to be cosine of arc cosine 2/3 times sine of 2 times arc sine negative 1/3. Now, dealing with this coefficient of 2, we're going to have to treat that like sine negative 1/3 plus sine negative 1/3. I'm sorry, arc sine of negative 1/3 plus arc sine of negative 1/3. So we're going to have to treat it like that, as if it's 2x equals x plus x. Now, there is an identity, and you can see that in the solution online, but in this case, we're just going to continue using this law to show how it's solved. And you can use the identity if that's quicker for you. This is just a more explanatory solution. So first, let's go ahead and define the cosine in terms of the sine so we can have it in these neat forms like over here. So in order to do that, we're going to have to draw that triangle like we said before. Let's go ahead and draw this triangle. This is going to be the angle that represents it. It's going to call it theta. So adjacent to that, because cosine is adjacent over hypotenuse, the adjacent of this is going to be 2, and the hypotenuse is going to be 3. Now, in order to find that in terms of sine, we need this opposite end, and that is going to be equal to x squared equals 9 minus 4, which is 3 squared and 2 squared, using Pythagorean theorem. That's going to be root 5, and we did say this, so this is going to be root 5. And then now what we can say is that sine, or arc sine rather, of opposite over hypotenuse is going to be root 5 over 3. And now what we do have is something along the lines of this or this, which is helpful for us, for our purposes. So what we're going to continue to do is go ahead and tackle this right here. what's going to happen here is we're actually going to apply a different rule of, we're going to apply a different rule of addition, and that's going to be the addition of cosines, and that's going to look like cosine A plus B is equal to cosine A cosine B minus sine A times sine B. So we're going to use that to apply this to that, because remember we're using this form, i.e. this. So that's going to be our A and B. So in this case, A and B are going to be the same, and we'll reference this by squaring it actually to make things a little bit quicker, although they can be made even more quicker if we use a certain identity that I haven't actually figured out what it is. So this is going to be cosine sine. Just to write it all out here, I already spoke this, but it's going to look something like this. And so what happens is A, B, cosine sine of arc sine negative 1/3, times, or this is actually squared. All right, so this is what I was coming to. So to take a step back, if this is becoming a little complicated already, as you can see, we're already filling up this OneNote page. Essentially what we're doing is, if I can take this specific part and move it over here, if I can just grab this specific section and show you exactly what's happening. So we did write that it's going to be, sorry to be repetitive, but that it's going to be the cosine of arc sine negative 1/3 plus arc sine negative 1/3, and that's the same as this, 2 times arc sine negative 1/3. And so we're using this law here in order to solve this. And now, since A and B are the same in this case because of the coefficient, which makes it x plus x, which essentially is the same, cosine A times cosine B is going to equal just cosine A or B, whatever, squared, because A and B are the same. So now that leaves us with cosine of negative 1/3 squared. And the reason why this is because, as I explained, A and B are the same. So that's going to leave us with, if we wanted to write it out, we could put this times that again, but we're just going to write s squared to make it easier on ourselves when we're simplifying it further. And now the other part, which is sine A times sine B, which is, remember, subtracted from cosine A times cosine B. And remember, in the law of adding angles and cosine, that's going to become something easier for us to use because it's already in arc sine. So we're going to put that negative sign from the law, and it's going to be sine of arc sine negative 1/3. This is also squared because of the fact that they're both the same, and we have to multiply it twice for this law to work. Well, because A and B are the same, so twice. But for that to work, and this is going to become, well, first we have to, right, so forgetting to draw the triangle here. Alright, so we're going to bring up the triangle all over again, except this time the opposite is 1, and the hypotenuse is 3. Let's go ahead and ignore the negative for now. So it's going to be this measurement here adjacent is going to be 9 minus 1 equals 8, which is the square root of 8. This is by the Pythagorean theorem, as you remember. It's going to be root 8, so the cosine equivalent of this, to make it easier on us to write, is going to be adjacent over hypotenuse, which is 8 over 3. And so that is going to leave us with cosine of arc cosine of 8 over 3 squared minus sine, or let's go ahead and solve this too. So this is going to be easier for us because we know that a sine and its inverse are going to just produce negative 1/3, which is then squared to make 1/9. Remember, this becomes positive, but this subtraction comes from the law of adding cosines, as you'll remember. And then this becomes root 8 over 3 squared, which is 8 over 9 minus 1/9 equals 7/9. So all of this is actually equal to 7/9. Now I'm going to pause right here so you can maybe pause the video or something if you want to take a look at this or screenshot this or ask any questions, because I'm going to go ahead and erase it after this point. Or, I'll just shrink it. So it's going to be a part of our process. Right. Clean up here. Okay. So that becomes 7/9. This, as you'll remember what we just solved, all that gigantic step was this, which we found was 7/9. And this is going to be root 5 over 3 from that process of sine and its inverse. So it's root 5 over 3 times 7/9. Now we have that part of the equation. So in terms of the scope of the whole problem, we've already solved this part. So now let's move on to cosine A times sine B, which should be a little easier. We're going to have to do all of this one more time, but it'll be simpler this time since we now know what we are doing. So in order to do this, let's go ahead and begin with the easy stuff. We know this is 2/3 minus, have this coefficient again. Now on the test, I can't remember if there were coefficients. I don't remember it being this hard, but in case you do ever run into it, just remember, if you can't remember identities to help you, 2x equals x plus x. It's going to give you the ability to use either law of sine addition or law of cosine addition. So basically what this is going to give us is sine arc sine negative 1/3 plus sine arc sine 1/3, and this time we're going to apply that same law for sines that we were using before. So it's kind of a law of addition of sines within a law of addition of sines. So it's like a sineception sort of thing going on here. So we have sine cosine B plus cosine A sine B, and this is A and this is B, but remember A and B are the same, so just take that into account. So this is going to be sine of sine arc sine negative 1/3 times cosine sine of arc sine, I'm sorry, negative 1/3 plus cosine arc sine negative 1/3 times sine 1/3. Now this all looks pretty long and intimidating, but really it's not that bad. If we really think about what's going on here, we're just doing this, and then all we have to do is simplify this twice because this is repeated here. So these both become negative 1/3 because of the sine and its inverse. So we already know half of it. We're halfway there. And so now we're going to form that triangle again. Remember that it's, because we're in sine, it's going to be opposite over hypotenuse, so kotoa. So it's going to be, let's call this theta, and 1 is the opposite, and 3 is hypotenuse. And so this side here is going to be, again, root 8, I believe. Yes, root 8. And root 8 is going to be part of that cosine that we're trying to form. We want this ideally to be arc cosine. So the cosine of this is going to be root 8 over 3, which means this can turn into cosine of arc cosine of root 8 over 3. Now this is good news for us because guess what? This can just turn into one of those easy things where we just put root 8 over 3 and we're 3/4 of the way there. Actually, we're done because we already did this. So it's root 8 over 3 again times negative 1/3 plus. So now we've got this going. So it's negative 8 over 3 plus negative 8 over 3. Now you might have noticed that a lot of steps were repeated, and that's because I was trying to explain how this process works in terms of implementing the signs of it all and adding everything together. But that was all to make negative 2 root 8 over, wait, okay, yes, all right, I'm sorry, negative 2 root 8 over 3, because there's 2 of them. So this can be simplified further, because negative 8 is also negative 4 times 2, and that can be taken out to 2. So you multiply 2 times the negative 2 that was already there, which means that's going to be negative 4 root 2 over 3. Right? Wrong, because I forgot to. Sorry. Oh boy. It's been a while. So this is, we forgot to multiply this. My fault. Okay, so it's going to be 9. So that is all to say this. Negative 4 times root 2 over 9. Now we have both sides of the equation because, but don't forget about this part. This part is missing, all of it will have been for naught. We do not want that. That would be really bad. So that would be 3, 4, 2, 9. And I'm almost positive I messed up the signs here. Now, I'm looking where, but let's go ahead and simplify this into 7 root 5 over 27 plus, this is going to be, let's see, sine, negative 3 and 1/3. Okay, so getting lost in my own problem here. Oh, right, oh, shoot. Darn it, okay. I was circling the wrong number. So let me go ahead and bring it. I'm sorry, that's so many mistakes. It's gonna make it really confusing. Okay, this is the number we were looking for. Remember, we were applying all of this to this law. It's gonna be 2/3. Let's see. Yeah, 2/3 times this. Yeah. Yeah, this is actually a multiplier. make this negative 8 to 7, 7 over 5, 27. Something we can simplify. 7 root 5 is 8 root 2 over 27. That is actually correct. Because this was so massive, and I got lost and confused each time, please let me know if you have any questions. And you can point out each step as I go along. Just let me know what point in the video it was where you got lost or might have confused, opened points for confusion.